Welcome to Spring LIB.
In this exercise, we have a soccer player who kicks a rock off a cliff, and 40 meters below the cliff, there is water, and the soccer player hears the splash of the water after a time of 3 seconds. So t prime equals 3 seconds. And given that the speed of the sound is 343 meters per second, we want to know what was the initial speed of the rock given that it was kicked horizontally. So this means that the initial speed in the we want to calculate the initial speed in the x direction because the initial speed in the y direction is 0. Also, I'm going to set up a coordinate system here, okay, such that the origin is at the water and just at the end of the cliff, and the y coordinate is pointing upwards, the x coordinate is pointing to the right. And given this choice of coordinates, we can write the equation for the y coordinate and the x coordinate as written here on as highlighted in red here. So the first thing I'm going to do is to calculate how much time it takes for the rock to reach the water. Okay, with that information we can then proceed to calculate the initial speed. So notice I'm going to use the first equation here. So the first equation is y equals y0 plus v0 yt minus 1/2 of gt squared. And I want to calculate the time it takes for the rock to reach the water. So when it reaches the water, y is 0. So we have 0 equals y0 plus v0y, but v0y is 0, minus 1/2 of gt squared. So we can isolate t here, and we have t equals the square root of 2y0 over g. So this is the square root of 2 times 40 divided by 9.8. This appears in meters, this down here is in meters per second squared. So the time is 2.85 second, 2.857 seconds. That's the time it takes for the rock to reach the water. And now we can calculate the time it takes for the sound to go from the water to the ear of the soccer player. So this is the total time it takes for the soccer player to hear the splash. This is the time between the soccer player kicking the rock and him hearing the splash minus t. That's the time it takes for the rock to reach the water. So this is 3 minus 2.85 seconds, so 57. So this is equal to 0.143 seconds. Okay. So this is the time it takes for the water to go from, the sound to go from the water to the soccer player's ears. So we can calculate the distance r that's traveled by the sound. Okay, that is the distance between the water, the exact place where the rock reached the water, and the soccer player. And this is just the speed of the sound times the time it took the sound to reach the soccer player. So this is 343 meters per second times 0.143 seconds. And this is 49.05. Let me just write it a little better. 49.05 meters. Okay, but notice that the height of the cliff is 40 meters. We want to find what is the distance d, the horizontal distance d, and the distance r here is equal to 49.05 meters. So since this is a rectangle triangle, we can find d. D squared is equal to r squared minus 40 squared. So d is equal to the square root of r squared minus 40 squared, and this is the square root of 49.05 squared minus 40 squared. So d is equal to 28.39 meters. Okay, so now we are in a position to calculate the initial speed. Remember that the initial speed is completely horizontal and no forces act on the rock horizontally before it reaches the water. So v0x is just d divided by the time t it took for the rock to reach the water. So this is 28.39 meters divided by t that we already calculated. That's 2.857 seconds. So this is 9.94 meters per second. And this is the initial speed.